Welcome to the second part on factoring for special products or special cases. And in this case it's factoring for difference of squares. Also, this is in combination with greatest common factors. So here we have an example, and if we look at these two terms, we see that what's in common to both terms, they're both divisible by 2. So I can pull the 2 out, and 2x squared divided by 2 leaves me with x squared, and then 8 divided by 2 leaves me with 4. So I've taken the greatest common factor, which is 2, and I've separated it from the rest. Now, if I look at this, this is the difference of two squares, another special case. X squared is x times x, and 4 is 2 times 2. So for this special case, to factor it, we just do the x minus 2 times the x plus 2. And we carry the greatest common factor down. So that's our solution for this expression. Now, if we want to verify that and see that yes, this is the answer, well, we can use the FOIL method. And if FOIL, first, outer, inner, last. So if we multiply the first terms, we have x squared. The outer would be x times 2, which is 2x. The inner would be minus 2 times x. Now we see that plus 2x and minus 2x is going to cancel each other out. So that's going to end up being a 0. And then the last terms, which is minus 2 times plus 2, gives us minus 4. So we're left with x squared minus 4. Of course, we got to carry the greatest common factor down, because we still have that to deal with. So if we take the 2 times that expression, we end up with 2x squared minus 8, which happens to be the expression we started out with. So yes, indeed, this method does work. Okay, now we're going to try a second example. Now if we look at this one, and we look to see now, the first thing I always do when I'm factoring is see, is there any common factor in each term? And I cancel that out. So in this case, I see that 2x is common to both terms. So I can pull 2x out, and I'm left with 2x divided by 2x is 1. 2xy squared divided by 2x leaves us with y squared. Now, if I look at this expression, I have 1 is the square of 1 times 1, and y squared is the square of y times y. So it's a difference of squares. So I can use that special case, and I end up with 1 minus y times 1 plus y. And of course we carry down the common factor that we separated out, 2x. And that's our solution. And again, if we want to verify that this is correct, we can use the FOIL method and go backwards back to where we started. FOIL, first, outer, inner, last. First, 1 times 1. Outer, 1 times y. Inner, minus y times 1. So we have a plus y and a minus y, which cancel each other out here. And then last, y times y minus y squared. So with the y minus y canceling out, we have 1 minus y squared. And the 2x common factor is still there, so we bring that down. And we multiply 2x times what's in the parentheses using the distributive property. 2x times 1 is 2x. 2x times minus y squared is minus 2xy squared. So we end up with the same expression we started with. So indeed, that method does work.